Hello everyone, and welcome back to Basis and Practice in Programming. In this lecture we are going to talk about a new topic. Somehow it's new and we had little overview about this topic before. We are going to talk about arrays. And for today's lecture we are going to talk about the following outlines. So the first we are going to talk about break continue statements. This is somehow related to previous lecture, but I did not include this one in last lecture because I don't want to make the lecture very long. And also we are going to talk about go to statement. Those are somehow not related to arrays, but I wanted to mention them before I start talking about arrays. And then we will talk about single dimension array in C language, and we will see different type of arrays and consideration we need to think about when we are creating arrays in C language. Then we will talk about how to generate some random numbers and use those random numbers, fill them inside array. We saw this one last lecture, but I would like to also mention this one again. We are going to talk about also multi-dimension arrays, and this is very important in real life applications. So arrays which have not in just one row, it will be multiple row, and we call this one multi-dimension arrays. Also we are going to talk about variable size arrays. That mean arrays which have size but it's not fixed size. Somehow the size of the array will be coming from variables. Okay, so before we start talking about arrays, I would like to just talk about continue and break statement. So let's see this one by this example here. In this example, we have a num, it's a variable, and then we print enter a secret number. As you see here, there is a secret value 8. And here we have a while loop. This while loop has a strange condition here. This condition is 1. 1 means true. That means this while loop will run forever. This is the meaning of while true. While true means this one will be true forever. In this case, maybe you will think, okay, if this loop run forever, this while loop will start from here and then finish in this one here. This loop will run forever executing this code. But I would like to tell you here that this code will not run forever. Why? Because there is here, inside the loop, I will say scanf. I will read some number. I will ask from the keyboard some number, and then this digit I will compare. If this number you inserted from the keyboard is equal to the constant value secret, which is here, is equal 8. If they are equal, in this case you will say correct. It's like a game. You guess. So if you put the number from the keyboard equal to the secret, in this I will tell you the message correct, congratulations. Okay, and then there is something interesting here. This one is a break. Break mean break the loop. Break the loop. Where is this? So this is the while loop. When I say break, that means it will jump outside of the loop. Okay, this is the meaning of this one. So break here mean break the loop. So if you put this one inside the loop, it will jump. If the condition is true, it will jump out of the loop. And in this case, the loop will never run again. Okay? Else, if you don't guess correctly, else, I will say try again, and then I will say continue. What does the continue mean? Continue mean just start again the loop. Go to the next execution of the loop. So this is the meaning of continue here. Continue mean you just jump to the beginning of the loop and execute the code again. This is the meaning of continue. So every time you see continue mean don't do anything, just go again and run the loop again one more time. Okay, this is the meaning of this one. Okay, so let's run this code together and see how this code will run. So I have code block code, and I will put this one here, and in this one here I'll say enter the secret code and okay, the secret number, and I will not forget about the okay. So let's see here. Okay, define, and then we see here secret, and it's equal 8, for example. Okay, this is the secret, and then here I will compare this one with the secret. Okay, so so this is the if statement, okay, and this is the else statement, and this is the while loop, and that's it. Okay, so let's see how I will recompile. Okay, so let's see. This is wrong, so I will change. Those one are usually wrong from the copy and paste from the. Okay, and also those are wrong. Same thing. Just the quotation. I need to change the quotation. Okay, I guess everything will be fine now. So let's run. Yeah, everything is fine. So run, and here is it. It will ask you. Okay, so let me just. Okay, so here is it. Enter a secret number. So if I say, for example, okay, let me run again. So if I say 4, it will try again, and then go to the loop again and ask again another number. 4, try again. 6, try again. Okay, so it will run forever until every time you will guess, it will tell you try again until you try the correct one. So if you try the correct one, it will break the loop. So if I say 8, here we go. Correct, congratulations, and the software finish. Okay, so the software in this case finish, and that's it. So the correct congratulations is this one, and then he will go outside of the loop and it will terminate the software. So this is the meaning of 1 here. So while 1 means run this loop forever, but the only way to break this loop is this one. This one will terminate the loop. Okay, without the break, you will never terminate the loop. Okay, so imagine I don't have a break. In this case, let's run this one again. I will rebuild and then I will run. So let's see here. If I say, for example, 5, it will try again. 6, try again. 7, try again. Maybe I'll say 8. 8 means correct. So it will tell me correct and still ask me again. 4, try again. 4, try again. 2, try again. 8, congratulations. So it will run forever, this one, okay? So the only way to break this one is the break statement here, okay? Hopefully this one is clear for all of you. Okay, so this is about continue and break. So usually break and continue, we saw break before in the switch statement. This is doing the same thing. Break means jump out and go to the next statement. What is the next statement? Next statement is the statement after while. After while is what? Terminate. Just terminate the software. If you have a statement after while, it will jump to that statement. Okay, now let's go to the next topic. The next thing is go-to. Go-to is only available inside C programming language, and also they adopt this go-to to C++, but still no one recommends to use go-to inside the software. So I really don't recommend you to use go-to, but I would like you to know this keyword. Why? Because maybe you will see some code over the internet and you will see that code include go-to. So you want to know what is this one doing. But for real life practice, this is go-to is not a good practice to use. Okay, don't use it if you can. Actually, no need for this one. We can do anything using go-to using another way, using programming language. So what is go-to? Here I have salary, a variable. I have age, and then I have here if age is more than 60. Okay, this is a condition. If age is more than 60, now yes, it's more than 60. In this case, I would say like this: salary is equal to the salary equal the old salary times 1.5, and then go to A. Where is A? This one. Go to A. This is a, we call this one a code label. We call this one code label. Okay. So this code label A, it will jump. So after this one, it will go. It will jump to here, and then execute. Salary is equal the old salary plus 100, and then salary equal the old salary plus 9 97. So that means these two statements will be executed, okay? And then it will print for you the salary is equal salary, and it will be like this. So look here, the old salary is 1,500 times 1.5, and this one will be 2,000, so it will be 25,000, and then 25,000 plus 197, it will be 22,000. Oh, sorry, this one will be 15. Okay, so we can do this one. So this one will be like this. You have, okay, so here is it. You have 15,000 times 1.5. So 15,000 times 1.5. This will be 22,500, and then plus 100, which is this one, plus 100 plus 97. Okay, the old salary plus 90. Okay, so it will be this one, and this is what you see here. Okay, now how about if I want to execute the else? If I execute else, let's see how the else will run. Imagine I don't have here 65. I have here this one age is equal, for example, 55. If this one is equal 55, in this case it will go to the else. Else will multiply 1.2, so the salary will be the 15,000 times 1.2, and then it will go to B. So it will only add to the salary this one, 97. Okay, so this is what is go to will do. So in this case, if you check the calculator, this one will be 15,000 times 1.2. This is the 18,000, and then plus go to B label. It will be plus 97, and this will be the result. So the result will be 18,097. So we can check this one here. So let's check this code. Okay, so we copy this one. Okay, so here we go. Here is the code, and now we will run it in the 65. So let's see, in 65 it will be salary equal, yes, as we saw in the output of the PPT. How about if I make this one like, for example, 55? Let's see if this one is equal this one or not. This one, 18,000. So I will run this one again. Yes, it will be 18,097. So as we saw in the calculator. Okay, so let's run. Next. Okay, now after we learn about go to and break and continue, let's go to arrays. So we saw arrays before, and we know somehow we saw several examples in the previous previous lectures about arrays. But today we are going to go a little bit in details about arrays and refresh or make your knowledge about arrays more concrete. So here, arrays, here we can define array like this. For example, this is an integer array, and now we put the size of the array here. So this is the size of the array. And then if the size, for example, 5, in this case, the array has 5 elements. Those elements will be like this. Array element number 0, and then array element number 1, array element number 2, array element number 3, and array element number 4. Okay? And now each element in the array will be the one integer, and usually integer size is 4 bytes. So this one 4 bytes of size, because it's one integer. I can put here one integer, and this one will be 4 byte, and this one will be 4 byte, 4 byte, and then 4 byte. Okay, so this one, that means the total size of the array will be 20 bytes. Okay, now each element in the array has address also, address of the elements. So for example, let's play with this array. So I will define this array and start playing with this array. Okay, so here, for example, I will say here is the array, and then I will see here, for example, print. Okay, printf. And then I will say here, for example, modulo D, and then I will put here size of, okay, size of the array. So let's see if the size of the array will be, okay, array. Okay, so I say, what is the size of this array? So let's see, yes, it's a 20. Okay, why 20? 4 times 5, okay? So how about if I want size of one element? So for example, element number, number 0, element number 0 size. It will tell you it's 4 bytes, okay? So 4 bytes, it's one element is 4 bytes. Okay, now if I put in the array, I can initialize this array like this. I can say, for example, element number 0 will have value 0. Element number 1 have value 1. Element number 2 have value 2. Element number 3 has value 3. And element number 4 has value 4. So those are 5 elements, okay? We can define like this. In this case, if I say what, okay, I put like this, and then I run, let's run this one. Yeah, this one here, when I put like this, what is this one? This one here is the address of the array. This is the address of the array. So each array has address. Okay, so if you put the name of the array alone, in this case, this one will be only address. Okay, but if you have here, you put between brackets, for example, 0 here. In this case, you will say, I want the value of that element. So I want the value of that element. So let's run. Yeah, so it will, this one mean the value of that element. I think some of you already know this one before, but just want to, so here I'm reading the value of that element. Now, if you want to know the address of that element, so that, because each element has, if you see here, each element has address also, machine address, it's in the memory. In your computer memory, this element inside this memory address, this element inside this memory address, for example. Okay, so in this case, if I want to see the address of that one, I will see here modulo P, mean pointer or address. And then I will say here, I want the address of this one. So I will put like this. I want the address of this one. So when I do like this, let's run. Yeah, this is the address. This is the address of the first element. Now let's remember this one here. Okay, this one is the address of the first element. How about we print here? But I don't put this one. I don't put this one. Just like this. The name of the array. Okay, so let's see what this one will print. Oh, sorry, I will put here maybe a new line, just to make these things easy to read, and then new line. Okay, and then execute. So what will happen here? What we have here? So the first element address in the memory, where is this one in the memory? The first element in the memory, in this address in the memory, in this computer address, okay? And the same, if you don't put zeros here between brackets 0, this is only the name of the array. Name of array is exactly the first element in the array. So the first element in the array is the name of the array. Okay, so this is the meaning of this one. Okay, so this is the same. So the address of the array is address of the first element in the array. How about the second element in the array? So okay, you can put the second element in the array, this one, and let's run. Yeah, you see the second element in the array is the same like the first element in the array plus 4 bytes. 4 bytes more. It exists in the second 4 bytes. Okay, and so on. So here, if you see in this one, the first element, for example, in 600,010, the second element will be in the same number plus 4, same number plus 8, same number plus 4. Sorry, this is a plus 4, plus 4, plus 4, plus 4. Okay, so this is the value or the hexa value. For example, this is just example, the hexa value of the elements of the array. If you want to see, here is example. We'll do the same idea I just mentioned. So let's see this example together. I will explain the example and also I will run the example. So here I create array, and this array has how many elements? It has n elements. So how much elements? 5 elements. Okay, that's good. So we will have 5 elements, and now this n is constant, mean 5. So here is it, 5 elements, and then I'll create some counter, and this one will be 0. Okay, and then I will say create another array. This is array of integer, and this is array of double. So I create 2 arrays, one array of double elements, and one array of integer elements. And then I will do what here? I will say make a loop, start from 0 until less than n. That means this loop will run how many times? It will run 5 times. It will run at I equals 0, 0, and then plus plus. I equal 1, and then I equal 2, I equal 3, I equal 4, and then I equal 5 will stop, because I must be less than 5. Okay, so this loop will run 5 times from 0 to 4. 0, 1, 2, 3, 4. So it will be 0, and the next time it will be 1, next time it will be 2, until I equal 4. Okay, and every time I will give, I say here, the element of this array, it will equal what? It will equal 5 minus I. So 5 minus 0, that means element number 0 will be 5. Element number 1, when this one is equal 1, it will be 5 minus 1 will be 4. So it will be equal 4. So let me just okay, so here we have an array of 5 elements. Okay, element number 1, element number 0, element number 1, element number 2, element number 3, element number 4. Okay, so the first loop, in the first loop, element number 0 will equal 5. And then element number 1, this will be element number 1 when I is plus. Element number 1 will equal 5 minus 1 will be 4. So this will be 4. And then element number 2 will be 3, because 5 minus 2 will be 3. And then this one will be 2, and this one will be 1. Okay, so this is what will be the contents of the array ARR underscore I. So this is the array ARR. Okay, then after that, what I did here, I say print this message, and then inside here I will put some digit. This digit will be what? I. So I say array I between brackets element number 0 equals some value. What is this value? Will be the value ARR array underscore II element number 0. Element number 0 will be 1 value. And saved at location in the memory, and then I'll say modulo P. Modulo P mean put address. Put address. What is this address? Will be the address of that element. Okay, the address of the element. Okay, I hope this one is clear. So this one will print on the screen something. It will print on the screen something like this one. So it will say the first part here, this one. Okay, so let's see. It will print on the screen ARI element number 0 equal 5 and save at location this one in the memory 6C. That means 6 and then C means 12. Okay, and then after that element number 1 will be 4 and save at location. Look here, this number plus 4, this number plus 4 will be 7, and this one will go 0 because this one will be 16. 16 mean go 1 here and 0 here. Okay, this is hexa value. And then element number 3 will be saved at this number plus 4, so it will be 7 4. The next one will be element number 3 will be 2 and will be saved at 7 plus 4, it will be, this is from 4, it will be 8. Okay, so this one here. So this is will print the elements of the array, the first one. Okay, now let's go to the second one. Second one is very similar to the first one. It will be go loop from 0 to 5. Okay, less than 5. That means it will be 5 steps. 0, 1, 2, 3, 4. And then every time, fill inside the array D. Array D is here. Fill inside this one double value. This double value will be what? N minus I. That means 5 minus 0. So 5 minus 0 over 5. So it will be 1. So this will be 5 over 5 equal 1. And see here, it's equal 1. Okay. So this one here equal 1. And saved at location. And this is another location. See? Another memory location. Different than this one. Okay. So this is another memory location. Who will put the array in a specific location? Not you. It will be the operating system. Windows save the array in a specific location. So we cannot control where is the array should save in the RAM or in your computer memory. Automatic, when you run the computer, you run the software, this location will be decided by the operating system. Okay, the next element number 1 will be 4 divided by 5. 4 divided by 5, this one. Element number 2 will be 5 minus 2 will be 3. 3 over 5 it will be this one. And so on. Okay. And everyone will be plus, plus, plus. Okay. And look here. The plus is how many? Every time you add one new element, the double value is how many bytes? Each double value is 8 bytes. So here 0, 0 plus 8. And then plus 8, plus 8, plus 8. So every time a new value will take 8 bytes. So if you would like to check, okay, if you would like to check this one, so let's go here. Before this one, I can print here. I say, for example, okay, print F. Okay, and then I will say here, for example, size of, okay, size of array, okay, ARR I equal, for example, modulo D. And then I will put here, for example, size of this array, okay, size of ARR, okay. And now we will do the same to print the size of another array, for example D, and this one will be size of D. Okay, so we will see both of them 5 elements, but they are different in the size. So let's go up. Size of the first array II will be 20. Okay, why? 5 times 4 equal 20. Now the size of D, it will be 5 times 8. 5 times 8 will be 40 bytes. So it will take 40 bytes. Okay, hopefully this one is clear for you. Okay, so this is how you can assign value for the array, and here is how to read the value of the array element. So this is this is to assign value for the element of the array, and this one to read the element of the array. Okay. Okay, so let's continue. Here's more examples about how to make array. So this one, look here. So this is array of a float. So this one has 365 elements. So this float array is fine. This is okay. Each element in the array will be float number. Okay, one float number. And this one is okay. This is array of 12 characters. So each element in the array will be 1 character, okay? And then this one is integer health. Oh, this has a problem. Why has a problem here? Because you did not decide what is the size of the array. So this one is wrong. You cannot make array without deciding the size of the array, okay? If you don't decide the size of the array, you must do it like this one. So look here. You must say equal, and then you put the elements of the array. When you put the elements of the array, we know what is the size of the array. So as you see here, we put the element of the array. That means we know this array is 3. Okay, this one automatic 3. But it's optional. If you put the elements of the array as initialization list, we call this one initialization list. If you put them in initialization list, in this case, no need for deciding the size of the array. Okay, now how about this one? Array of this one integer array, that means all elements are integer, and the size is n. N is what? Constant here. You see n? N is a constant. How about this one? Integer age, no size. This is wrong, okay? So this is okay, this is wrong. How about this one? Without this, it's okay. Without size, it's okay because you put initialization here. How about if I put size and also put initialization? It's okay? Yes, it's okay. Okay, so this is how you can define single dimension array. Okay, so here's also more emphasize. So initialization list. So you can initializing the array. So you can say, for example, integer counter equal 5. This is equal 0, 0, 0, 0, 0. Okay, look here. This one mean you are initializing all elements of the array. Let's discard and let's focus on this one. So if I see here this one, and then I will go here, and then let me delete this one all. Okay, if I see here, if I say this one equal 5, and then I will make a loop. For example, I would say integer I equals 0, and then I would say for loop start from I equals 0 to I less than 5, because this array is 5 elements. Okay, I plus plus. Okay, so this is the same. Okay, here is the array, and then here I will say print. I will print all elements of the array. So I will say here create, print some digit, and then create tab. That's it. Okay, and here what I will print, for example, counter or counters, and this one I will print element I. Okay, element I print. So let's see this one. Yeah, here is it. You see 0, 0, 0, and between these zeros are tab. So 5 zeros. 1, 2, 3, 4, 5. So this is 5 zeros. Okay, so how about if I put here just how about if I put here 1, 1, 1, 1. All of them are 1. So let's run. I have something in my mind to show you here. So all of them are 1, 1, 1. How about if I put, because though all of them are equal, all of them are ones, I put just one like this. Let's see. So here, yeah, this one, in this case, it automatic will be, this is 1 and this one will be zeros. Okay, so be careful about this point. Okay, so this one you say put 1, that means others will be zeros. How about if I don't put anything, no initialization list, no initialization list at all, I don't initialize anything, just I want to say what will be inside this one. You might ask, okay, but there is nothing inside them, so let's see what will be inside this one. So I will close this one. What is inside? Garbage, just garbage. You see here, this is element number 1, just garbage from my computer memory, and this is another garbage from the memory. This is another garbage for the third element. Fourth element is here, garbage. Fifth element is garbage. So if you don't initialize, give value for the elements, you must give them value by loop. If you don't give value by loop, it will include garbage. And in the later, if you want to use the elements with the garbage without initialization, it will make garbage. So what I recommend you to do is to do like this. Every time when you create an array, you will do like this. Okay, so let's run again one more time. Automatic, all of them will be zeros. Okay, so I really recommend you to do this one so you will not have any mistake in the future. Even if this one double, yes, even if this one is double, that's fine. Okay, so you can put this one here and then you say this one is double. Okay, so this way you can have, yeah, you will be safe about initializing the array. If you don't initialize, in this case, you must initialize by loop. How to initialize by loop? Same like what we saw in the previous example. After you do like this, you will say, for example, you will create some loop. For example, the same loop, I will copy and paste, and this loop will be like this. Just I will say counter I equals 0, for example. So this one, I will say initialize this one. So give value for this one. So because I did not initialize here, give value 0, for example. And then do whatever you want. Okay, if we run, all elements will be 0, you see? Why? Because I put this sentence here, this loop. Okay, without this loop, if you delete this loop and run again, in this case you will get garbage from the memory. Okay, so be careful about this point. Okay, so initialization list, we can array, and then you will say this is element number A, B, so this is character array, and then you can give characters here if you want. If it's a float, you can give a float numbers. So in C language, you can do this kind of initialization list when you initialize the elements of the array to initialize all elements of the array. Here is also another practice about arrays, something to consider. So look here, float array 5. This is okay. That means I create array of 5 elements. That's fine. How about this one? Float array, and this array contain, oh, there is some expression here. So this expression, the result of this expression here, m is number, and those numbers, everyone is number. So in this case, the result of this one will be one number, and that number sure will be integer number. So in this case, 2 times 5 plus 5 plus 1. So this one will be 10 plus 5, 15 plus 1 will be 16. So that means this one, 16 elements. So in this case, no problem. If you put expression here, no problem. But this one is here, the m here is integer or constant, and this one here is integers all, that's fine. How about this one? Yes, this one is also fine. N is a constant here and it's integer, and m is a constant and it's integer. In this case, integer and integer will be one integer, and the integer will be 8. That means this one is fine. How about this one? Float A4, and this is 2.5. Oh, this is dangerous. This is wrong. So you cannot say I want the number of elements. I want the number of elements to be 2.5. There is no elements 2.5. Okay. So the number here inside here, the number must be integer. Must be integer. Must be integer. But if you have a float, it will error. It will show error. So this one is wrong. How about this one? No, you cannot have array of elements 0. You cannot have array of 0 element. Okay, so this one is also wrong. At least you have like 1 element or 2 element or whatever. Okay, here, how about this one? This one will be 8. 8 is integer. Divide by another integer. So integer divide by integer will be integer. Integer divide by integer will be integer. So this one will be 4 elements. So this one is okay. How about this one? This one will be integer divide by another integer. But be careful, 8 divided by 3 will be some fraction. But because this one is integer and this one is integer, the result will be integer. Okay, so the result will be integer. That means this one will be, so this one will be something like this. It will be 8 divided by 3. It will be 2 only. There is no 0.6 because why? It will be here 2. Why 2? Because this is integer and this is integer. So this is integer and integer. The result will be integer. Integer what? It will be only 2. 0.6 will not be reported. So this will be okay. So this one is fine. How about this one? Oh, this is wrong. Why wrong? Because this is double. Double divide by integer will result will be double. Double, that means this one will be 2.6. 2.6 is wrong because 2.6 there is no array size 2.6. It must be integer. So this one will be wrong. Okay. How about this one? This one is 3.1. The size is 3.1, but I say convert it to integer. Convert it to integer, casting. This one is casting here. So I'm doing casting. So I'm converting 3.1 to number, to integer. So it will be 3. So this one will be fine. So this will be array of 3 elements. Okay, so this is some examples. So what we know from this this one, when you define array, when you say integer and you have defined array, between brackets here must be some integer value. Okay, this is what we want to know from this slide. You need to put here integer value. Okay, so let's see some more examples about array, just to let you practice more. So indeed here we want to create the Fibonacci number sequence. The Fibonacci sequence here is, maybe you know, some of you, this is a study from math. So we create array of 15 number. Okay, so 15 number of array. Then I say here Fibonacci 0. So the element number, so in this array contain 15 elements. Element number 0 will have value 0, okay, based on this statement. So look here, this statement say Fibonacci, the array, element number 0 equals 0. So here is it. And then same thing, Fibonacci element number 1 will be equal 1. So the element number 1 will equal 1. Okay, that's good. And now after that we did some array loop. This loop started from number 2, from I equal 2 to I less than 15. So from I, because as you know, this array started from element 0 and the last element in the array will be element number 14. Okay, from 0 to 14 will be 15 elements. So I say from starting from element number 2, that means this guy here, starting from element number 2, I equal 2. I equal 2 is equal what? This element equal element number I minus 2. I minus 2 mean what? Element number 0. Because I is equal, first loop, I is equal to 2 minus 2 will be 0. So it will be element number 0, plus element number I minus 1. 2 minus 1 will be 1. So that means element number 1. So it will be element number 0 and element number 1. So it will be value of element number 0 plus the value of element number 1. And this one will be element number. So that means it will be what? 0 plus 1 will be equal 1. Yes. And then let's go to the next loop. The next loop, I plus plus. I plus plus, that means this one will be what? 3. I equal 3. So element number 3 will be what? Element number 3 will equal element number 3 minus 2 equal 1. So this will be element number 1 plus 3 minus 1 will be 2. So that means element number 2. So it will be element number 1 plus element number 2. Element number 1 plus element number 2 will be 1 plus 1 will be equal 2. So this is the equal 2. Okay. And then again, I equal 4. For element number 4, okay, element number 4 equal what? Element number 4 minus 2 will be 2. Element number 2. And then this one will be 4 minus 1 will be 3. So element number 3. So element number 2 and element number 3. Element number 2 is 1. Element number 3 is 2. So this one will be 3. And so on. We continue. So every time the next element will be the sum of this element and this element, the previous two elements. So this one, element number 5 will be 5. Element number 6 equal will be 8. Element number, this will be 8. And this one, element number 7 will be 13, and so on. We will continue. Okay, this will continue. Okay, so this loop will fill all elements of the array. And then what is this one doing? The second loop. The second loop go from element number 0 to element number 15. Print what? Print on the screen those elements. That's it. Print this element as integer. Okay, so print those elements. So it will print element number 0, element number 1, element number 2, element number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so this is what we call it Fibonacci sequence. Okay, I hope this one is clear. Okay, so more examples. So we will see more examples here. Here is this example, but this one, each example has little bit extra things. So here I have array of 6 elements. Okay, that's good. And then I will print, for example, here I say size of the array is element 6. So this is array will be 6 elements. And then I will say here print a, and then there is digit. These digits come from II, so that means element number 0, element number, it will be like this, element number 0, element number 1, element number 2, element number 3, okay? And then modulo P here mean what? Print address. P mean address. So I'll print the address of that element. So the address of that element, the address of element 0, and then the address of element 1, and then the address of element 2, address of element 2. So every time a plus 4, plus 4, plus 4, plus 4. Why? Because it's integer. Okay? But we can do the same thing. You see this part here? This one to print the address of the element. Okay? We can do this one exact the same example, but here I would say first element of the array, A is what? A is equal element number 0. So this is the address of the first element. Look here. Same result. Okay? But plus, so the address of this element plus II. Plus II, this is the second element, and this will be the second element. Same number. Okay? Address of the third element, here is it, third element. So what I want to say here, what I want to tell you from this example, you can access the address of the element of the array using this way, like and then the name of the array, and then between square brackets you will put the integer, the counter. Okay? This is to access the element address of the element. Or you can access the address of the element using A, the name of the array, plus whatever you want, numbers. So this will be address of the array also. So this way or this way, it's up to you. Okay? Okay, so let's stop here for the array, and then I will continue talking about arrays in the next video. So far we talk in this video, we talk about break, and we say break to break out of the loop. So if you put this one inside the loop, if the condition is, usually we put it after condition. If this condition is true, it will break. Break means go outside of the loop. And also we learn in this lecture also about continue. We say continue mean you will go and run the loop from the beginning again. Also something we learn in this lecture, in this video, is go to. Go to, it will jump to some label A. If you put A, for example, or B, or any label here, it will jump to this label and to run the code starting from this code label. So if you say go to Tamer, okay, here, for example, go to Tamer. In this case, it will find where is Tamer, label Tamer, and it will jump where and run the code of Tamer. Okay, so you can put any label you want, but you need to define this label and then put some code here and start running from where is the code label exist. Also, we learn in this video about how to define array, and we learn several examples about how to define array, how to give value for the elements of the array, and read the elements of the array, and also read the address of the array elements. Okay, that's it for this video, and we will continue talking about arrays more in the next video. Thank you.